Hello everyone, welcome to another video from me. This video is specifically geared to answer some questions that I've had about section 8.5, which is the chi-square test for variance and standard deviation. So let me open my screen share at this time and show you what we're dealing with. The question that somebody asked regarded the answer key for number 2 and number 3, I'm assuming, but number 2 in particular, the p-value calculation. This is just slightly different than what you're used to. So let me scroll back to number 2 here. Find the p-value interval for each chi-square test value. So obviously we have to pay attention to what the chi-square, the sigma square is. We have to pay attention to n, and we have to pay attention to the tails, and I'll show you more about that in a minute. One thing to remember about the chi-square curve is that it is right skewed and it doesn't have negative numbers. So the first one here says sigma squared is 29.321, n is 16, right tail. So here we have something that looks like this. You don't have to draw these, but if it helps you, you certainly can. This is your line. Your chi-square curve, I'm going to make the line a little thicker so it'll be a little more friendly for us here. This curve is right skewed, so it's going to have a hump on the left. It's going to have a right skew. That's very bad. But basically, because we don't have negatives, we start from 0. And that's one thing to remember about this curve. That looks more normal. Let me erase that, try one more time. So here, let's try this. We're going to go here. We're going to go up, make a curve, and then drop way, way, way down. Something like that. I mean, that's really skewed, but you get the idea. Here's my value, right? So this is a right tail. So let me put it in the correct tail distribution here. Let me erase this and put this in the correct tail distribution. So we're looking at this, just to remind you, our chi-squared is, and I'm using X because Zoom doesn't let me use Greek letters, 29.321. My n is 16. And my test is right tailed, okay? So that means I'm looking at something that looks like this. I don't know where this is exactly, but this is my chi-squared right here. Now my p-value is going to be in the direction that my tail area is going. So my p-value is going to be here. Now, one thing to keep in mind, as I said, the chi-square doesn't have negatives, so this is going to be 0 there. And so what that means is when you go to the calculator, a couple of things before we do that. Remember that chi-squared uses degrees of freedom. So you need to reduce this by 1. This is n minus 1, which is going to give us 16 minus 1, which is 15. Okay, so what I'm going to have here when I do this is 2a. Okay, and I'm going to have my chi-squared is going to be my chi-squared. Now, don't make the mistake that I made when I did this problem the first time. You're gonna see two things on your calculator. Make sure you're using the CDF, not the PDF, as in Paul. Chi-squared CDF, this is a right tail. So you're gonna go from chi-squared, which is 29.321 to infinity, E99, with a degree of freedom of 15. Let me show you all of that. I'm going to do a new share. If you need help with that, go to your critical value p-value chart right here. Calculate the test value. You're doing a right tail. So we're doing the one in the middle. Area to the right of chi-squared and df. So your chi-squared number, E99 df. When you put that in the calculator, that looks like this. Now, I have the PDF at the top just to show you the difference, okay? You want the one at the bottom. So what we want here is 0.0146 should be our answer. 0.0146. You want to make sure you're using the CDF. So once again, second distribution, chi-squared CDF. This one here, number 8 for me, 29.321 E99. Remember your DF is 15. Paste it. There's my number. Okay. And if we take it back to the solution, let's take it back to the homework here. Let me stop sharing and put the new share up. This is my new share here. You can see that you scroll down, 0.015. She rounded to 3. If we round to 4, we get 0.146. If you round it, you get 0.015. So that does match. Okay. Let me do the others for you here. So this, the second one is going to be, let's do this now. Let me share the screen. So if I scroll up here, the second one says chi-squared is 10.215 and is 25 left tail. 10.215, 25 left. So this is going to be this is going to be chi-squared is going to be 10.215 and is 25. And we're talking about a left tail test. So here, if you want to see what this would look like, again, not necessary to draw it, but if you'd like, you certainly can. This is your right skew distribution. So we have our hump on the left and our skew. Forgive my not so lovely curve. Left tail tests were somewhere here. So this is going to be 10.215. This is going to be your chi-square number. Now, remember, there are no negatives. This is 0 on this side. So then, if we go back to, we're looking now at shading the left tail, which means we're shading this portion here. Okay. So this time we're not going to infinity. This is 0 to this number, 10.215. Let me show you on the actual sheet. So if you go to the critical value p-value sheet, left tail test is at the top. For left tail test, the p-value is chi-squared area to the left of chi-squared. df, you start with 0, go to chi-squared, put the df in there. So if I do that, I'm going to end up with something that looks like this. I'm going to have my p-value here is going to be is going to be chi-squared CDF we have 0, we have 10.215, and my DF will be 24. Remember, my DF is 1 less than n. So DF is equal to n minus 1, which is 25 minus 1, or 24. So that's 24. Okay. And so we're going to put 24 in here. And that's going to give us something else. Let's look on the calculator. Let me share the calculator screen here. And I have second distribution, chi-squared CDF, number 8. My lower is 0. My lower or my left is 0. My upper is 10.215. My DF is 24. And I paste it. So then I have 0.00639. So that's 0.0064 if I round to 4 places. 0.0064 to 3 places, I match her answer, 0.0064. So this is going to equal 0.0064. Okay, that's my p-value. 2C, I believe 2C is the one that is two-tailed. Let me take a look, because that one is the one that's a little different. I want to show you that one. Yeah, 2C is 24.672 and is 11 two-tailed. 24.672. So in this case, we have two of them. We have one p-value, but we have two critical numbers here. What our value ended up as, we need to know which side this is on. We don't know. We know this is 0 here, but we don't know where 24.672 falls. Is it on the left or is it on the right? We don't know that. That's why we have another step. So here, this one, 2C, this is for 2C down here. This is 2C. So we have chi-squared. This is chi-squared is 24.672. And it's DF is 11. And it's 2 tails. Now, this is how we figure out where our chi-square is, because we don't know if it's on the left or the right. So let me share with you this one. I'm going to stop sharing the whiteboard for a minute, and I'm going to come back to the CCCVPV, and it says, for a two-tailed test, if chi-squared is less than DF, then the p-value is 2 times the left side, essentially 0 to chi-squared. If your chi-squared value, remember they gave you that, is larger than your DF, then the p-value is 2 times the chi-square right, which is chi-squared E99. So in this case, that's going to be, let me show you. Here's my numbers, right? So my N is 11. I think I put DF. Let me change this because I have an error here. Let me change this part. So this is chi-squared. Let me go back to the problem here. This is N is 11, 2 tail, 24.672. So here you have chi-squared is 24.672. N is 11. I made an error when I typed that before. And it's a two-tail test. So DF here is 10. Now what we have to do is compare DF to my chi-squared. My chi-squared here is larger than my DF. That means that my chi-squared is going to be, that means my chi-squared is going to end up being over here. Okay, this is where my chi-square is. And I know that because of what I just showed you. And I'll write it here on the whiteboard for your convenience. Since chi-squared is greater than DF, greater than the degree of freedom, okay? This is essentially, we're going to have my p-value the p-value is going to be equal to 2 times chi-squared CDF from 24.672 E99 and my degree of freedom, which is 10. So let's put that in the calculator really quickly and let's see what we end up with. So I'm going to stop sharing this and say I have second distribution chi-squared CDF. Enter. This is 24.672. I'm doing E99. I want to do it to the end here. My degree of freedom is 10. And I'm going to paste it in. So that is 0.0060. Remember, I have to multiply that by 2, which I'm going to do after the fact. So I'm going to go ahead now, multiply this number by 2, and say that my final answer is 0.0120. 0.0120. So here I have, this is equal to 0.0120. And if I check that with Professor Nigdel's answer, let me stop sharing this and switch screens. We have, let's scroll down. Point 0.012, which is what works. You should get 0.003 for part D, which is just a right tail test, 23.722. I'll give you the format. You can check the answer on your own. But the format for this, it's a right tail test, just like A. So it's going to be p-value is equal to chi-squared CDF from 23.722 E99. DF is 8. And you should get, if you did that correctly, hopefully, we should match her answer. Let's take a look. So we have 23 point, here's my calculator, second distribution. Now we're doing chi-squared CDF. We have 23.722 E99. Degrees of freedom is 8. Paste it. 0.0025, which rounds to 0.003. You'd end up with 0.0026, actually, if you rounded to 4. 0.0026 is what you would have here. Okay, I hope that helps you. Number 3 will be coming in a different video. But I will see you very soon, folks. Take care. I hope this was helpful to you. Talk to you soon. Bye for now. Let me